So the first one is continuous uniform. Okay, uniform. I'll write it in small. Uniform distribution, very commonly used in machine learning. Okay, so this is that all outcomes within a range, within a whatever is the given range, all the outcomes are equally likely. It is also called fair. Okay, fair distribution, that all the outcomes are equally likely. So this is mostly, so I'll write it down for you, that all outcomes in a given range are equally likely. That's why the name comes, equally likely to occur. That's why it's also called fair. Everyone gets an equal opportunity. The most common use is random number generation, where we want every number to be equally probable. So random number generation is the most useful application of uniform distribution. Okay, that's the practical thing. And so this is generally denoted by, let me give you the denotation. So x we give now when we say this, right? So this means belongs to, and these are the symbols now. So this means that this random variable x belongs to a uniform distribution in the range a to b. Okay, range a to b, and this is given by, this is equal to f of x. Okay, I'll leave that out. 1 by b minus a for a is less than equal to x is less than equal to b, and 0 otherwise. Okay, within this range, this is 1 by b minus a, constant for all. Okay, and if we draw the PDF, right, how will it be? If you draw the PDF, this is a, this is b, b is greater than a, so this will look like this. So if this is b, this is a, what will be this value? This value will be b minus a from here to here. And if this is b minus a, and we know that the complete probability or the area under this curve should always be equal to 1. So this area is equal to 1. This is a rectangle. So what is the area of a rectangle? Length into breadth is equal to 1. We know that this breadth is b minus a into length is equal to, we want to find what is this value. This value here is equal to 1. So what will be this? Length will be equal to 1 by b minus a. So that is what is the value here. This is the probability. This is 0. Okay, so this is your uniform, and the value in this region, if you see that every value from here to here is having equal probability, that is 1 by b minus a. Okay, I hope this is clear. So there is one special case of this. So let me give you some more information. This is just good to know that there is a special case of uniform distribution, that is when the range is from a to b. So that is from 0 to 1. That is called standard uniform distribution. Standard uniform distribution. Okay, when the range is from 0 to 1, so we say that is standard, and that is what is used for the random number generation. And here f of x will be equal to 1. Why? Because a is 0, b is 1. This implies b minus a is equal to 1. And we know the formula, right? This is 1 by b minus a. So this is given by this is equal to 1 and 0 otherwise in this range. So this will be in the for all x, or 0 is less than x is equal to 1, given this. Okay, there are some more properties around this that is known, that is studied, that variance is given by p minus a whole square by 12. Okay, and then the mean here is equal to median. These are statistical properties that are known. That's what I said, right? That once we have formulated a real world problem into a random variable and we know its distribution, then there are a lot of statistical properties that is readily available for that distribution that can be used for a mathematical analysis, and we'll know a lot of information about the problem that we have at hand now. So once we have identified that our problem can be modeled as a uniform distribution, then we can say that now we have so many information about that the variance of that will be given a b minus a square by 2. The mean and median will be same. Its value will be b plus a by 2, and lot many more information about this. So that's why modeling a real world problem into probability distribution is helpful. Okay, that's the real benefit.